Hello and welcome back. Let's talk about another interview question in Java. For some of you, this might be beginner concepts, but I'm sure it's going to help you a lot for your interview preparation in Java. We're mainly going to talk about primitive types in Java, especially the numeric primitive types. We're asked to write a function that accepts a double value or a double number as an input and determines which primitive number the data types can be stored. So that we don't lose any information. Okay, I'm sure you're gonna learn something from this video. Please watch that till end of this video. So we in Java we have 8 primitive types basically, and that's why we cannot tell that Java is 100% object-oriented programming language, but we could say it's purely object-oriented programming language, because these primitive types, the 8 primitive types, they are not object, they are not reference type, but they are simple data types, or they call it primitive data type. Out of that 8 primitive data types, 6 of them are numeric primitive data type. We have byte, short, integer, long, float, and double. And out of the 6, 4 of them are numeric, or it's integer. We would say whole numbers, we can store whole numbers, but 2 of them float and doubles. Besides, we can store the integer values or whole numbers. We can also store floating point numbers, okay, or decimal numbers in these two. But they differ in their size and the number of precision that they can store in them. Okay, so our requirement is to write a function that accepts a double value, and we want to check in which data types, primitive data types, this double value or double number can fit. Okay, so what we can do is, before we get started, let's get an idea of the size or the values or the range of the primitive types in Java. We know the byte is 1 byte or 8-bit is going to take 8-bit values, and the range for that is -128 and go all the way up to a positive 127. We have a different range for short type. It takes 2 bytes or 16-bit, and it has almost -32,000 to positive 32,000. So to get this information, Java provides wrapper classes for these primitive types, or the object or classes for these simple types that starts with the capital letter. So for example, byte, the byte class or wrapper class starts with capital B. So let's take a look here. What I'm going to do is I'm going to print some information about this primitive type. Then we can start solving and write a function to solve this problem. Okay. So, but before that, let's see what we can print. I'll say s out. Just want to print something here. I just want to print the information about byte data type. I'll say byte. Byte information, something like this. Then I will say how many bytes or the memory a byte data type will take. I'll say the size of this. I'll say size of maybe byte is, I will say, I can access the wrapper class for that. For byte, we have a wrapper class byte which comes from the java.lang package. If I click here and if I go and take a look at its documentation, we can read about its documentation. We can see it is a public final class, okay, that extends number. It stores numeric values and numeric data type, and also it's comparable. We can compare that. Okay, so it is a wrapper class for the byte data type, and the primitive type is, if you want to define a byte data type, we can say byte for example, number equal to 10. Okay, we can do something like this. But this is the wrapper class or the object type or reference type for the byte primitive type. Okay, so if I take a look at this class here, I'll say byte. If I press Control and click on that again, we can see this class can hold some information or properties about the byte. We can see the minimum value. We can access the minimum value we can store in this data type, and the maximum value. We can get the size of this data type, like how many bytes in memory it occupies. So using this class, we can access on some methods and features or properties of the byte data type. Okay. Since this is a primitive type or a simple type, I cannot access anything with that. If I press dot, I don't see any method um, or any field for that. But if I take the wrapper class, I'll say byte dot, I can see a lot of methods and properties of this class. Okay, so what I can do is I can print the size of each data type, primitive data type, using the wrapper class. I'll say byte, which is a class name, dot byte. This is a property. It indicates the size of this data type. It's going to take this much bytes in memory. I'll say this much bytes. And I can also just, let's say I want to print the maximum and the minimum value we can store in that. I'll say minimum value. I'll say the byte class dot min value is going to show me what is the minimum value that we can store in this data type. I can also print the, I'll press Ctrl D to duplicate this line, and I can just print the maximum value that we can store in this data type. I'll say the max value. Let's see. What I can do is put a max here. I'll say byte dot max value this time. It's going to give me the maximum value. If I print that, let's see, it's going to give me the information about byte data type. So byte information, the size is 1 byte or 8-bit inside memory, and the minimum range we can store in a byte data type is -128. The maximum is positive 127. We can do the same with other types. What I can do is maybe I can just print a new line here, just to separate them. This time I want to store print information about short data type. We have short data type, and I can see the size. This time I'm going to call the short wrapper class short.byte is going to give me the size that this data type occupies in memory. The minimum, I can say short, the class name, the wrapper class dot minimum value. I can say short dot maximum value. I can do the same with integer. We know we have integer. Let me say integer or int information, the int data type. I can say integer. The wrapper class for that is integer dot byte. The size of that, I believe it's going to take 4 bytes, and I can print the maximum value, the minimum value. Let's see, integer dot max value, main value, etc. Okay, I can do the same with long, or with floating point, with double, with character, with boolean, etc. Let's do with boolean also, or let's do with double. Let's see how much memory a double takes and how much memory a long takes. Okay, you can definitely print the information about boolean, about character, and other primitive data types. So what I can do, I can paste one for double and one for long. Okay, we know double is floating point number, and I'll say the wrapper class for double is double dot bytes. It's going to give me the amount of memory it takes, and I can get it is minimum value, maximum value, and etc. Okay, and I can also print the long. Long is another data type. I will say this time, let's see how much bytes a long data type can take and what is the max and min value for the long data type. Okay, once we got this information, we can easily solve that problem. Let me run this program very quickly. We can see the double is going to take 8 bits, and this is the range for its minimum and maximum value. Okay, that's 4 times 10 to the power of 9, I believe. It's a scientific notation, and it's long information also takes 8 bytes, and it has a greater range than integer value. For integer, I believe we can store 4 billion numbers, minus 2 billion up to positive 2 billion numbers, something like that, and it's a bigger number. Okay, so once we can print this information, what we can do is I'm gonna get rid of all of these, and let's solve our problem. Okay, it says write a function that takes a double. Okay, what I can do is I can just write a function here, public static. It's not going to return anything, or we can just return a list of types or whatever, but I just want to print that. Okay, public static void, I will say primitive type fit, something like that. It's going to accept a double. I'll say value, and inside here first I want to check if this value is an integer value or a floating point value. Is it a whole number or a floating point number? How can I do that? If it is a floating point, let's see. I have double num equal to 4, maybe 8. Okay, to check whether it is an integer value or a whole number, we know if we take a look here, we know it's a whole number, not a floating point number. I can say just print value or num equal to if the num is equal to the type, if we typecast it to a long, if it is equal to the long version of that, or maybe integer value of that, then it is an integer. Okay, so what I can do is I can typecast this to a long, and I'll say num. Okay, it's going to return me true. Okay, but if I have 8 point for example 8, and this time when I typecast that, it's going to remove the decimal number, okay, the floating point, and it's going to return me 8. So 8 is not equal to 8.8, so in that case it's going to return false. Let's see. Okay, it returns false. So when we typecast to an integer or a long, it's going to remove the decimal point. Okay, and it's going to return the whole integer. If I print that, for example, is out integer, I'm gonna typecast it to integer this time of num, it's going to print me only 8. Okay, and get rid of the decimal point. Okay, this way we can check if a number is a whole number or an integer or not. I'll say I can define a boolean um, is um, is whole number, something like this, is whole number or is integer equal to, I will say, take the value and check if it is equal to, when we typecast it back to a long maybe or an integer. I'm gonna change it to a long because double is 8 bytes and integer is 4 bytes. In that case, if I take integer here and if we pass a number that is greater than the range of integer, then we will lose some information. So the requirement is that we want to print without losing any information. Okay, in that case I just can use long because long is also 8 byte and double is also 8 byte. I can say value. I want to typecast the value. I'll check if is whole number. If it is a whole number, I know that it's going to either gonna be fit in these 4. Okay, out of this 6 primitive type, 4 of them we can use to store integer values or whole numbers, and 2 of them are used to store floating point numbers. Okay, so what I can do, if it is a whole number, I can do something here, else I'll say I'll check if it is in the range of floating point number. I'll say if the value is less than or equal to floating point or float data type dot, I will say it should be less than the maximum value. than max value, and also it should be value should be greater or equal to floating point or float class dot main value. Okay, something like that. If it is the case, I just want to print this out. It can fit in a float data type. Okay, I just can print float. And in all case, since it is a double, we accept a double value. In all case, no matter if it is a whole number or if it is a floating point number, it will fit in a double type. Okay, what I can do is out of the if else loop here, I can just print it can fit in a double data type. Okay, something like this. But what happens if it is a whole number or an integer? Then we're gonna check if it is going to fit in byte. If we can print byte, if it fits in short, we can print short. We're gonna start from the smallest and go to the longest. Okay, or the smallest to biggest. So what I can do is I will check if the value is greater or equal to byte class dot a main value, and at the same time it is between the range. Okay, I'll say value should be less than or equal to byte class dot max value. If it is in this range, I know it's going to be fit in a byte data type, so I can just print byte. Okay, I can just print it can fit in byte data type. If it fit in the byte data type, it's going to be definitely fit in short and int and long also. Okay, but if it doesn't fit in byte, we can check if it fits in short and long and int. Okay, so what I can do is maybe I can just do something like this. I can say maybe I can copy this, try to be a little bit lazy. I can say if the value is greater or equal to the short dot main value and it's less than or equal to short dot max value, sorry, and this should be max value. Okay, not main value, this should be max value, and this also should be max value. If this is the case, I just want to print it it can fit in a short data type. Also, I want to check if it is going to fit in a integer. I'll say if it is if the value is greater or equal to integer dot main value, check if it is in the range of the integer. I'll say integer dot max value. In that case, we know this number is going to fit in int data type. I am gonna also check if it fits in a long. I'll say long dot main value, and it should be less than or equal to long dot max value. In that case, I just want to print long. Okay, something like this. Value should be greater than or equal to, and it should be long dot max value. Okay, like we get an error, is always true. Okay, value should be greater or equal to long dot main value. Yeah, it's correct. Okay, it should be less than the max value. Let's see and call our function. I'll say just call the function primitive fit, and I can pass some double. I'll say 4. Let's say 4 should fit in all data types except the floating point. Float it fit in byte, it fit in short, and fit in int, long, and double. It's not a floating point number, so that's why we not print floating points. So it is a float. Now let's pass a floating point number 4.3. It should fit in float and double. Okay, let's see. It fits in double, but it doesn't fit in floating point. Okay, if the value is less than or equal to floating point dot max, and value should be greater than, this should be main. Okay, main value, and I'll just remove this one. Let's see. It fits in float and double, and what I can do is this time maybe I can increase the range. I'll say 400 45. It's not going to fit in short and byte, but it is going to fit in short. Okay, int, long, and double. I believe short range was 32,000. Let's make it 44,000, 44, something like this. It's not going to fit in short, but it fits in int and long and double. What I can do is maybe I can increase the size a little bit. Let's see. It still fits in int. Put another 0. It still fits in int. We put it too much. Let's see. This time it fits in int, but if I put some floating point number here, let's see. It's going to fit in floating point and double. Okay. So thank you so much for watching, and please don't forget to subscribe. And if you have another good solution, please comment out your solution, and see you in the next video. Bye bye.